I practice at TCS. I'm going to get straight into the conversation so we don't waste time. So Brendan, maybe if you could let us know what Avery Dennison does.
Absolutely.
It's a company that actually does a lot of things, but most people don't know about it. It'd be good for you to get a sense of what you
do. Certainly. So Avery Dennison has been a manufacturing company for over 90 years, and a lot of our products are unseen, but are ones that we engage with every day. So even on your person right now, you have perhaps a tag or a sticker on the back of your neck that's scratching you. Sorry, that's us. We're a label manufacturing company, and we label pretty much all consumer goods and products across the entire globe. And to do that, we have separated our organization into two main focus areas. One is Materials Group, which is focused on the actual stock, the material, the inks, the adhesives to actually stick that Starbucks sticker onto your mugs. And then we have a secondary organization in our enterprise that is focused on the actual labeling solutions, the branding, and all of the basically patches that you see from NBA players as an example, all of the branding and items that go into apparel as an example as well. So we touch many different industries across logistics, supply chain, apparel, even airlines. All of our labeling solutions can be found pretty much in everything you touch every day.
Great. So just a quick follow-up there, right? As TCS, we work with thousands of companies on AI. I can tell you that your company profile is exactly the kind of company that usually is not the most forward-looking when it comes to AI adoption, and yet Avery Dennison, and I've seen this for the last 2.5 years, has been pretty much at the frontier of really pushing forward on AI adoption. So if you could maybe briefly speak to us about how did you guys get started, and what have you achieved so far, and where things are at the moment?
Certainly. So our AI journey, really, I think the aha moment for everyone that happened around like the ChatGPT launch, where LLMs finally became a tool that was effective in business, really was a sparking moment for us. And my team is the Digital Innovation Center of Excellence in our corporate entity. So we are the ideation pipeline for digital tools and technologies of the organization. So we actually started when that aha moment happened. We ran a global ideation session from all of our different teams across our business units, and we generated over 550 opportunities or ideas to actually implement AI. And in our first year, my team, through heavy prioritization and also working through funding and also just what is valuable for our business, we actually executed 24 POCs, and 17 of them actually went to production and to scale, which from, I think, also in the industry is a percentage
absolutely. It's a very high percentage, actually.
Yeah, and I think that's actually due to the nature of our company. Our culture really is actually very strong innovators in our material science domain especially, and we have a lot of smart individuals who would love to be tapping their curiosity more, and I think we've tapped a nerve with AI, providing tools and capabilities to our teams that are actually effective.
Brilliant. So Rishikesh, I'm going to get straight to you, since usually when we see large companies, especially in the manufacturing space, adopt AI, they do so in safe areas. They do that in finance, they do that in HR and IT, just to get their hands wet. And yet, in Avery Dennison, we find that you've gotten straight to the crux, at the heart of what it is that you do, which is material science. I want you to talk us through how you adopted this, and how did you manage to get a bunch of scientists to actually change their ways of working to adopt this?
Yeah, thank you for that question. So Avery, of course, there's a very strong sense of innovation. Our key material science domain is we make tons of sticky stuff, but this is sticky stuff that's somewhat special, where it is a pressure-sensitive adhesive, which was invented by our founder, Stan Avery. When it comes to the adoption, I co-lead digitalization for R&D, and a big part of this is really how do we go faster? How do we innovate faster, which is true for many companies? And also, how do you innovate with certainty? So a lot of these elements are around making sure that you not only bring in fantastic experimentation, but also good physics-based simulations, and now increasingly with AI and ML tools to sort of integrate across all of these discrete domains and bring them together. So that is the spirit of it. And Avery has always been, a very early adopter of most things. And actually, one of the things I just wanted to add to Brendan is we are an outstanding roll-to-roll manufacturing company. So we are a powerhouse. The speeds at which we do things are truly remarkable. So even in our manufacturing, you will see a lot of AI adoption. But here, it is no longer a choice. It is a necessity. It has to have happened. There is no way for us to scale things to do it the same old manner. So that would be I'll end there unless you want me to enunciate any other parts.
No, I think I'm particularly keen, for the audience, given that the amount of hype around AI is so much, right? Yep. What people are always sort of really hungry for is a very first principle sense of, so you've built these two assistants and agents for yourself. Could you maybe walk us through what problems that you had that you felt were truly, genuinely best solved by applying generative AI here?
Sure. So I'll just lay a background to that to say, and this is not unique to Avery Dennison. This is for most companies in material science, chemical sciences, where reconciling a large historic expertise in any scientific discipline is a very big problem. And that is really what we took on 5 years ago when we started this journey in building very strongly curated model-ready databases. And in most material science companies, unlike life sciences or even unlike the semiconductor industry, the information is not as strongly curated. And that's a fundamental problem, that you have to have good information, accurate information you can build on. So that's the number one problem is generating information, filling in that gap with, and that's a long, hard process. It's really a labor of love. But now once you have that, you go into building a model-ready database. Then there is the elementary problem where there may be navigating a material science space or a specialty, but then there is the act of making a product. Yes. And these two elements are different. One relies on the other, but it's not always the best material science is needed to make a good product, and you will see that all around. So those are some of the key problems just in generating the information that is necessary. And there you now see there's a huge movement in material sciences around autonomous self-driving labs. How do you combine high-throughput materials development with AI-augmented optimization? So those are all journeys that we have to take, and they're all very expensive journeys. Making new materials is by far the most expensive thing you can undertake. And so automating that would be the nirvana of the agentic AI from that perspective, from a scientific perspective. The other difficulty here is correctness. What is the truth? So that requires strong domain expertise. So the more we go into these tools when it comes to scientific applications, technical applications in this realm, requires greater expertise on the person to say, is this thing spitting out the right answers? So that's a part that we have to navigate. And most importantly, and this is not unique to Avery, is the adoption, is the upskilling of your R&D force, the readiness with which they may do things differently. In fact, the way you experiment to build model-ready databases, physics-informed AI, and then to wrap it with easy-to-use tools like LLMs. And I just heard Google unroll their knowledge catalog that I heard from this morning. So those are all, I think, elements where this is resonating. But the key difficulty is that core material science part.
So I'm going to sort of, Brendan, given the unique, highly sort of sensitive proprietary knowledge where you guys have applied this, it'll be good for you to walk us through, and you mentioned the whole idea of prioritization of use cases, right? I see companies struggle to do this, right? So the reason why a lot of AI implementations end up stopping at POCs is that they often did not prioritize the high impact, high value use cases, and also were willing to take that risk. So walk us through how you managed to convince a bunch of scientists to actually take this up and start to deliver value.
Certainly. So getting back to those 550 opportunities for implementing AI, the prioritization of that was really based on what my team does every day. So we take and ingest ideas basically in a sales pipeline behavior, like across the entire function and the globe of employees. So those ideas weren't ones that were coming from the top, they were generated from a grassroots. And I think that's the motivation and the culture that we actually wanted to leverage when it came to adopting AI. So we actually distilled that from not only the benefit that it would bring, quantifying the potential revenue growth, the revenue protection and compliance, as well as the cost benefit, but supplementing that as well with a feasibility analysis, and not just from a technical feasibility, but more from the feasibility that our teams would actually use it. And what's great about Rishi's team and the R&D team is that the ideas that they sparked, they also had the intention of basically, if we were successful, had the funding in place to take it to scale.
Right.
So that was obviously a factor in our decision making of even if the POC was successful, it actually had sustainable legs post POC. So those were the ones that we ultimately prioritized and why they went to scale. Because the teams themselves actually created the space and the culture to actually adopt these AI tools.
Perfect. And Rishi, I think the one thing that you said sort of sparked my interest, which is the whole idea of getting your scientists to also think in terms of how to use these things, right? And as someone who works with multiple companies, a very common pattern I see is that fundamentally the difference between people who get AI versus people who still use it like a tool is the difference between what I call the scarcity mindset and the abundance mindset, right? All of us, many of the people who work for you would have done PhDs, come through a time when your ways of working largely are influenced by what compute you have available, where are the constraints, where time is valuable, where this knowledge of minimum viable product is built on top of a business that you run and so on, right? And all of a sudden, you now have this new technology that allows you to spin up 50 different experiments simultaneously, parallelly, generate synthetic data, find patterns that humans could not otherwise find. This abundance mindset thinking, I want us to sort of, how do you see this shaping the culture of your research organization going forward?
So I think when it comes to product development, certainly at the end of the day, Avery Dennison, regardless of AI or not, we have to sell something that's tangible and make a buck at it. The key part of this is really in navigating large parameter spaces. And that's where the techniques like machine learning, AI, excel is large parameter spaces. So that would be the way you de-risk is to be able to perform the experiments on a computer to digital twins and so on and so forth, to de-risk it in that way. And that comes somewhat naturally, certainly for people that may be trained in certainly physics-based computations and so on and so forth, is how do you flatten the problem so that you're not trialing 100 different things.
Right.
You're only trialing maybe 10 of these and saying, okay, which one among these might I finally consider to take it to market. So that, I think, would be one main element, is large parameter spaces. The second element of this is also when it comes to R&D information, particularly in our space, you will have multi-fidelity data. You will have lots of low-quality data but only a very little of the high quality data. And that's where all of our effort is that high quality data, and then how do you use that to temper your low quality and then make it a good outcome at the end of the day. But navigating that is the true essence of the technical virtuosity here, and that's what creates the separation, and that will be the main separator between companies going forward.
So, Brendan, I mean, I think, this entire process of prioritizing and then finding the actual problem, and then also finding the shape of the solution, the requirements, et cetera, et cetera. Talk us through, for example, he spoke about the culture change required within research to adopt it. Maybe talk us through the culture change required within IT itself to work in this new space of being a lot more in touch with actual end user needs, iterating fast, being able to scale it, productionize it, fixing it, and chances are you build something 6 months later, the product company is going to say, hey, this is now out of the box,
it's already built.
and so you got to retire it. So how do you navigate this new world of abundance and almost a chaotic mess of new capabilities coming all the time?
Yeah. To touch on, I guess, traditional IT versus where IT is going, there's no way that if we have empowered tools and empowered people across the company who can build their own apps, who can build their own agents, there's no way that IT really has a place to say, don't move forward. Innovation is going to outpace the ability for IT to scale and sustain the organization. And I think that's the major culture shift, not only in IT, but what's happening in the organization. Because we find the compound benefit of AI happens at the individual layer. So every individual now has unlocked potential and the ability to create value for the organization. So technology is no longer a stop. So that's the culture shift that has to occur at the individual level and at our different functions as well. So that's where I see a lot of great opportunities for us, is IT actually taking a step back and not inhibiting the business from innovating and reaching their potential.
Yeah, I think it's a change that as hard, in fact, I'm finding IT departments finding it harder to change than business, and this goes to a very interesting cultural, behavioral thing that I see in companies, which is that we're often fantastic human beings are fantastic at adopting technology that makes them better at something that they were not good at, than adopting technology that does something that they do slightly better, right?
Indeed.
So I often find that traditional enterprise developers resist too much, autonomous coding, because they feel that it gets to the crux of what the meaning of their own careers and so on. But we're happy to use, language translation tools. We're happy to use data science tools simply because I'm not a great data scientist, so I could use those to, Google's new tools and Colab and other things to do that work and so on. Is that a cultural battle that you're also sort of seeing within your own department?
Yeah, I think to your point, there is all manner of human emotions in this. There is the insecurity that, oh wow, there is now this massive database that is navigable with great accuracy, and does that diminish my own importance / security, whatever the case may be. So the key there is really the way we message it in Avery, certainly within R&D, is this is a thought partner. This is to enable you. This is by no means to replace you. And why would we do and fall into familiar patterns that are not very efficient if you can adopt this and then leave more time for the human to do the most critical part, which is to think of new stuff. The AI is not going to be filling that gap for you. It will be a great partner and enabler to you, but so I think that's a part that everybody will cross that bridge on their timeline. I am not sure I have the answer for how to make that go faster. But typically, it should not be that difficult in a technical environment, because by nature, by their education, they are taught to be curious and be experimenters. But yes, this has produced some very weird, typically, and I'll end on this note, most people that are used to doing it a certain way, and if there is a model presented to them, Either there is absolutely no belief in the model, or if the model spits out an answer, it should be perfect. Neither of these extremes are true.
You're
in
right,
fact, they're
yes.
very crazy extremes. So the truth is somewhere in the middle, and you will find people. And really, the key thing here is, as you notch up successes by using these tools rigorously in a scientific, technical forum, they will gain more and more acceptance. In fact, you will be left behind if you are not accepting them. So.
Absolutely. I think a natural follow-up to that is that I think it'd be good for you to speak about, I think, your journey of how you perhaps started out with some early experimentation with some of the older models in the Google ecosystem to eventually Gemini Enterprise, and to finally building these two assistants, for knowledge as well as your weathering and so on, which are highly niche, high value agents used directly in the things that most contributes, IP to your company and so on.
Yeah.
So what was a journey in terms of how did you mature along with the product stack, and how was the whole implementation story?
So, yeah, there's definitely a mix of outcomes from each of these POCs. Some of the things we've tested were really technology-based, but those were not meant to instill a new technology. They were meant for learning as to how these technologies actually work and function, and the outcome of those weren't necessarily having like a new app or a new tool. It was actually, we created knowledge in our teams. So now they're more educated to think about, if we're going to build, say, an agentic solution, they know the tools, how to plug and play and do them naturally. So the POCs that were successful for that perspective pays dividends in being more intelligent for how we do new projects. But then there's also instances where we did build, say, like a little chatbot or something on, say, Gemini 1.5, and Gemini 3.1 now completely offers in what we took 6 months to build is now available out of the box in 5 minutes. So we also have to understand that basically rewriting the tool set every day, because what is available for us now is going to be obsolete in a week. So in the same way that I was talking about how IT can't get in the way, we're now focusing primarily on building platforms and guardrails, not gates. So Rishi's team, if they needed 6 months in the past to really curate, say, a chatbot, now they have the tools to do so in just a couple minutes. There's no sense for us as an IT or technology organization to say, don't do that.
Great. So that sort of brings me to, I'm going to ask a slightly more tricky philosophical question about the arc of where this is going, right? So we've gone from ChatGPT moment literally 2 to 3 years ago to a world where now, as you saw in the keynote today from Thomas, that you could just simply in natural language sit and configure agents that are going to get work done for you autonomously, right? And in natural language, you could describe what good looks like, what an evaluation, what a reward function needs to be, and so on. And in this kind of world, if you logically extend it as companies get this, and as employees get it, and so on, a deeper existential question is that this represents a foundational democratization of skill, and not just shallow skill, but a reasonably deeper and deeper skills. As we've seen enough examples of people designing their own, cancer therapies using LLMs and so on. So that hype aside, do you, as a company and as a material science researcher, think about what this means about creating intellectual property in a world where this is democratized? So how do you sort of tell your researchers in your company that, hey, that's not where the value is? As you mentioned something, that it's the product that matters, not the breakthrough in the material itself, which anybody could now potentially do in their backyard.
Indeed, that's a great point you made. As you add layers and layers on a product, it could be a physical product, it could be even a software product, then you start building more and more differentiators. So that's always a good thing. But sometimes the material itself is the product. And that itself was the discriminating value. Now, fortunately, I think, yes, there is the danger that a group of competent scientists in one company, in 3M, which is our competitor in acrylic PSAs, if this group of scientists said, what is the best way to make a acrylic PSA, what's the best set of monomers to use, what's the best polymer to make, and then you have Avery's best scientists ask the same and answer the same question with these tools, the danger is they will come to the same gate, right? But I feel that that danger might be tempered by just this very fact that it is the product ultimately that you sell, which has to do multiple things. And in finding it to optimize multiple dimensions, you are now navigating a surface that looks very corrugated. So you may fall in a minimum somewhere here, and somebody else, an equally good set or even smarter set of individuals may land at a slightly different, so it's a very, very, imagine a mountain with lots and lots of sub-peaks and valleys, and that is, I think, the saving grace. Why, despite there is going to be this kind of, for frontier material science, make a battery material that replaces lithium ion, reduce the fear of fire, or increase the energy density. Those are definitely triangulating. You are going to that deeper and deeper energy minimum to find the solution. And at some point, you will not solve it any further. We are already with ASML at that limit, right? 2 nanometers or 3 nanometers. So
indeed. It's sort of, I think, it's always interesting how I regularly keep getting reminded that while these neural networks are fantastic at finding patterns in large amounts of data, this neural network is good at finding patterns in sparse data.
Yeah.
And sort of navigating those unknowns and having a sense of judgment and good taste, and very complex I remember when I was growing up in India that people would buy materials and electronics and these tape recorders from overseas, and they would sometimes just melt in the Indian heat.
Yep.
And then beyond a point of time, you started having a seal that said tropicalized. So these were materials that wouldn't melt in the Indian heat and so on. And so, the AI model is probably not going to catch those kinds of unknowns.
Right.
Yeah.
Sometimes we actually intentionally violate good rules of making something because you're trying to make it do something else. And most products are really balancing very contrarian requirements, right? That's, you could take anything, really. The thing that you mentioned, I just want to quickly touch upon, which is the intellectual property. This is the key area, right? Companies spend lots of money, and there is no way any human being can go and read up, even in a given domain area, to say, we've gotten this knowledge map of this IP map of this area, and then we can safely go here or there. And I think this is one area that I'm surprised has not been tapped into by most people, but I think that is just there for the taking. So,
indeed. All right. So, and I think, Brendan, as you sort of look forward to your agentic future, if you will, right? You've gotten so far, I think, clearly the adoption of conversational assistants and more niche, highly business and science-centric assistants seems to have taken off, and the adoption is pretty good, and so on. Where do you go from here, and how do you take that larger leap that I find a lot of companies struggling, which is how do I go from simply an assistant that helps me, but I set the terms of what help I want, to eventually assistants that autonomously go do stuff.
Oh, yeah.
So what is your thinking in terms of how do you do this within your organization?
Yeah, I mean, the thinking is really how to do this at scale and what's the benefit of all of these tools is it's just lowering the barrier to entry to build something with technology.
Yeah.
And once that barrier is low enough, and we're starting to see it happen across all of our employee base, that they're able to basically spin up an application that services their specific need. We had, even just last week, I had someone in our HR department who's never coded in their life, made an application for a mentor-mentee program, and they want to deploy it now for the whole enterprise. And they did that in a matter of a day or two of just trying out things with these tools. So the barrier to entry is becoming so low that all of our individual problems that we have in our own individual workflows, we'll be able to actually tackle those problems. And allowing our teams to solve them on their own is where we start. And where it goes beyond that is then all of these little tools that we each build is making them available for others to utilize as well.
Yeah.
So we're building, those visibility platforms that showcase this, either say a Gemini gem over here or an agent over here that this team built. Now we can make that plug and play across all of our functions and all of our teams. So it's that scalable platform mindset that is really, I think, going to enable this future. And where it leads to is hopefully a better running optimization of the enterprise.
Yeah. Yeah, in fact, I think it's interesting you mentioned this a month and a half back. My team ran one of the largest hackathons at the AI Summit in India. Mm-hmm. It was an interesting twist on it, which was none of the participants had ever coded in their lives. They were all arts, humanities, commerce, law, agriculture, students, and so on. And what was stunning is that, and in fact, they used Gemini and Google AI Studio to sort of think about, ideate, generate a requirements document, and then build a prototype. I can tell you, they built better applications in the sense of what problem they were solving than engineers would have done. So this is, again, which goes to, again, another philosophical question, which is that this broader generalization that the availability of AI, availability of tools, Gemini and so on, is going to make the what, knowing what good looks like, what correct looks like, what ethical looks like, what a good product looks like, far more valuable than the how. Right? Do you believe it's too much of a generalization? Are there still some blind spots where the how is going to trip you up in your area?
I think so. I think there are significant blind spots, and in fact, this whole revolution is nothing like it in the history of mankind, where we are so eager, in fact, to believe anything this spits out. Whereas our entire training, regardless of which discipline, has been where you've been taught to be critical and develop a mindset to question before you accept it. But somehow we are all falling over each other to believe whatever comes out of this. So that makes it even more important that the people in these domains, it doesn't matter if you're asking ChatGPT, how should I reply to my boss or something like this. But if you're saying, how do I develop the next cancer drug, you better hope that this is actually navigating properly and giving you accurate information. So I think it will never take away from the spirit of inquiry, and that's why I led earlier on to your other question, which was it is something that enables you to scan large spaces, flatten a problem very quickly, and that's the way it should be used. So there is a great danger that it will be taken up, and there will be an overuse of it as well, because what we don't want to do is to destroy the human virtuosity. That's going to be always, it will always be timeless in my view. These are all just going to make life easier from my perspective. But yes, we have to have very healthy guardrails, and that is one that I'm very, at some point a tool becomes a crutch. And you don't want that to be. So you want this to be genuinely, and then if you have a screwdriver and you have a nail, or if you have only a hammer in your hand, everything looks like a nail. So you will hit it with the same hammer. So,
right.
So those would be some elements to be watchful.
And what about, in the IT space, in the enterprise IT space, right? I mean, we definitely see how the world looks like to hard practitioners in deep science and material sciences, in healthcare and drug discovery, and in some of these very heavily regulated industries, insurance and so on, right? And yet, IT has always been this sort of very interesting new age knowledge, right? I mean, it's barely 50 years old, right? Yeah. How do you see your own sort of department and the way you think about your function mature as AI keeps getting better and better, more and more autonomous? most code. I mean, today we heard that 75% of all code written at Google Cloud was written by AI, right? And how does this shape your thinking in terms of what kind of skills are you going to be looking forward?
I think it's great that 75% of new code is generated by AI, but 90% of our code no one has seen in 20 years.
Right.
So I think a lot of the benefit that we're going to see is actually the advancement of our tooling and actually the migration off of legacy technologies that are just unable to move the needle.
Yeah.
So the unification and harmonization into newer technologies, newer tech stacks, I think is just going to accelerate. And that means from a hiring and resource talent perspective, we need to have top talent in a way. They say that a lot of like software engineering jobs are going down. I completely disagree, because the barrier to entry to all organizations that historically perhaps didn't need top talent in software engineering now needs it.
Absolutely.
And we're definitely one of those companies.
Yeah, I think the role is going to change. Their outcomes that they can deliver and the time frames they'll deliver, it will change. But you're probably going to need more, not less, and so on. So, on that note, given that we have roughly about 10 minutes.